How does the typical consumer choose what they will consume? We know that marketers try to persuade us to consume products and services. But what if we were not swayed and consumed only what gave us the most personal satisfaction possible? First, we realize that we must choose because we cannot have everything. This constraint on the consumer is called the budget constraint and can be represented by the graph we see here. Let's take Jose for example. He has an income of $56. This represents his budget. Jose consumes two items, movies and t-shirts. The movies cost $7 a piece and the t-shirts cost $14 a piece. The points on the budget constraint line show the combinations of movies and t-shirts that are affordable to Jose. The satisfaction received from consuming things is called utility. In the case of t-shirts and movies, we can see that Jose's total utility for each product increases as he consumes more of it. If we combine the total utilities of both t-shirts and movies, we can see that Jose's total combined utility for each point on the budget constraint is shown here. In order to learn how to best maximize Jose's utility within his budget, we must first learn the concept of marginal utility and how to calculate it. Marginal utility is the additional utility or incremental utility provided by one additional unit of consumption. And we can calculate it using this equation, which is the change in total utility divided by the change in quantity. We can see on our table of data that the marginal utility for each additional unit is getting smaller as we consume more units. This is called the Law of Diminishing Marginal Utility. Because the price per unit for t-shirts and movies are not equal, Jose finds it difficult to compare the two. That's why we must divide the marginal utilities by the price to allow us to compare the two. Again, maximizing his utility. Again, Jose is looking at maximizing his utility based on his budget constraint. We can calculate the marginal utility per dollar by dividing the marginal utility by the price. Now that Jose is able to compare t-shirts to movies based on the marginal utility per dollar, he can apply the utility maximization rule, which is that utility is at its greatest if we consume at the combination where the marginal utilities per dollar of each product are equal. In the case of our example, at point S on the budget constraint curve, marginal utility per dollar for t-shirts and movies is equal at 1.6. Another way that might be more intuitive to approach utility maximization is to use the consumer equilibrium approach. This approach asserts that the ratio of the prices for the products, in this case t-shirts and movies, is equal to the ratio of the marginal utilities at the point where utility is maximized, which as we know is point S on the budget constraint line. What if our income increases or decreases? Would our utility maximization mix stay the same? The answer depends on what type of products we are choosing between, normal goods or inferior goods. Here is an example. The utility maximizing choice on the original budget constraint is M. The dashed horizontal and vertical lines extending through M allow you to see at a glance whether the quantity consumed of goods on the new budget constraint is higher or lower than on the original budget constraint. On the new budget constraint, a choice like N would be made if both goods are normal goods. If overnight stays, in this case, is an inferior good, a choice like P will be made. If concert tickets are an inferior good, a choice like Q will be made. What if the price of one or both products change? How does that change our utility maximization mix? The original utility maximizing choice is M in this graph. When the price rises, the budget constraint shifts to the left. The dashed lines make it possible to see at a glance whether the new consumption choice involves less of both goods or less of one good or more of the other. The new possible choices would be fewer baseball bats and more cameras, like point H, or less of both goods, as at point J. Choice K would mean that the higher price of bats led to exactly the same quantity of bats being consumed, but fewer cameras. Choices like L are ruled out as theoretically possible, but highly unlikely in the real world, because they would mean that a higher price for baseball bats means a greater quantity consumed of baseball bats. Consumers demand what gives them the most utility for the price. This is basically what utility maximization is. We see on these graphs that we can extend the utility maximization exercise into the realm of demand curves. In the upper graph, we see that S is the price for housing increases from P0 to P1 to P2 to P3. The budget constraint on the upper part of the diagram shifts to the left. The utility maximizing choice changes from MO to M1 to M2 to M3. As a result, the quantity demanded for housing shifts from QO to Q1 to Q2 to Q3, ceteris paribus. The demand curve graphs each combination of the price of housing and the quantity of housing demanded, ceteris paribus. Indeed, the quantities of housing are the same at the points on both upper and lower graphs. Thus, the original price of housing, PO, and the original quantity of housing, QO, appear on the demand curve as point EO. The higher price for housing, P1, and the corresponding lower quantity demanded for housing, Q1, appear on the demand curve as point E. Here we are, using the same model of the consumption choice budget constraint. But in this case, we are choosing how many hours to work versus how many hours to spend on leisure type activities. Let's say that our original choice is point O on the lower opportunity set. A rise in our wage causes our opportunity set to swing upward. In response to the increase in wages, we can make a range of different choices available to us. A choice like D, which involves less work, and a choice like B, which involves the same amount of work, but more income. Or a choice like A, which involves more work and a considerably more income. Our personal preferences will determine which choice we make. Here is an interesting supply curve, which shows us the supply of labor. The bottom upward sloping portion of the labor supply curve shows us as wages increase over this range, the quantity of hours worked also increases. The middle, nearly vertical portion of the labor supply curve shows us that as wages increase over this range, the quantity of hours worked changes very little. The backward bending portion of the labor supply curve at the top shows that as wages increase over this range, the quantity of hours worked actually decreases. All three of these possibilities can be derived from how a change in wages causes movement in the labor-leisure budget constraint, thus different choices by different individuals. The decision of how much of our income to save for the future or spend today is an example of an intertemporal choice. Personal savings were about 7 to 11% of personal income for most of the years from the late 1950s up to the early 1990s. Since then, the rate of personal savings has fallen substantially, although it seems to have bounced back a bit in 2008. The choice to save versus consume is based on future expectations, which is where we get the term intertemporal. The savings versus consumption decision can be analyzed using an intertemporal budget constraint, like the one pictured here. John will make a choice between present and future consumption. With an annual rate of return of 6%, he decides that his utility will be highest at point B. which represents a choice of $800,000 in present consumption and $1,148,000 in future consumption. When the annual rate of return, or the price of money, rises to 9%, the intertemporal budget constraint pivots up. John could choose to take the gains from his higher rate of return in several forms. More present saving and much higher future consumption, J. The same present saving and higher future consumption, K. More present consumption and more future consumption, L. Or more present consumption and the same future consumption, M. So why do people increase their consumption of higher education and training during an economic downturn, when most other products and services are consumed at a lower rate? We see in this graph that this choice can pay off in the future. Those with the highest degrees in 2012 had substantially lower unemployment rates, whereas those with the least formal education suffered from the highest unemployment rates. The national median average weekly income was $815, and the national unemployment average in 2012 was 6.8%. Making a good choice economically is often seen as a rational decision, but as behavioral economics proves that people do not always choose rationally.